Hey, everybody, this is Alex Merced, and welcome to the special community edition workshop as part of the Gnarly Data Waves program. So basically, today what we're going to be doing is creating a data lakehouse on your laptop, and I, Alex Merced, developer advocate here at Dremio, will be your chaperone this morning, evening, depending where you are. But with no further ado, let's get on to our feature presentation, and that is going to be creating a data lakehouse on your laptop. And essentially, we're going to be using three components to build a data lakehouse today using Docker on our laptop. So if you don't have Docker, feel free to use this time during the slides to download Docker at docker.com. But essentially, we're going to be using Dremio as our data lakehouse platform. And again, what a data lakehouse platform does, it takes all the pieces that make a data lakehouse and wraps them together in a nice bow. So that way, your data lakehouse has the same sort of ease of use, unified experience that you usually would have on a data warehouse without with more openness, I guess. Then we're going to have Nessie, which will act as our data lakehouse catalog. And then we'll have Minio, which will act as our data lake on our laptop, basically our storage for our analytical data. Okay, but first let's talk more about that whole data lakehouse platform, because Dremio is the unified lakehouse platform for self-service analytics. And again, what it's bringing to the table is just kind of packaging everything together, giving you sort of three sort of levers of value. One is unified analytics, where it's going to basically allow you to connect all your data in one place and be able to deliver it anywhere through different interfaces like ODBC, JDBC, REST, Aeroflight. So again, taking that data from your databases, your data warehouses, your data lakes, and delivering it to your notebooks, applications, and data science. A SQL query engine that is fast and allows you to federate queries against all those sources, whether they are on-prem or in the cloud, and Lakehouse Management Service. So that way, as you make the data lake the center of your data gravity, it becomes really easy to do so, because things like managing your tables are things that are just automated and abstracted away by the Dremio platform, which can be deployed either through Dremio's Self-Managed Enterprise Edition, which you can use our Kubernetes Helm chart to deploy very easily into your Kubernetes environment or a Kubernetes environment, and Dremio Cloud, which is even easier because you just sign up, you connect your Azure or AWS cloud, and you're good to go. You have your data lakehouse platform connected, and you're off to the races. Okay, and today would be again using Community Edition, which is sort of the free edition of our self-managed software. But again, one of the benefits of using Dremio is that, again, it's going to allow you and give you the platform that allows you to do more of your data workloads that you would normally do in your data warehouse and shift left. So instead of having to go ETL that data and then prepare data marts in the data warehouse, you can just do all that work from the data lake, reduce your data movement, reduce the number of workloads, which means you can get data to where it needs to be faster and also reduce your costs. And again, this is all brought to you by Dremio's intuitive self-service experience, intelligent query engine, and next-generation data ops capabilities, again, which fall into those three tiers, such as Dremio's unified analytics that allows you to take any data to anywhere, that allows you to govern that data from one single place with a really easy-to-use interface, which you'll see later today when we set up that lakehouse. So again, you can connect several different data sources from all across your data sources. And again, it's not like everyone has like 50 different data sources, but some people do. Some people might be using 2 or 3 data sources. But wherever your data is, you can connect it in and then deliver it to your favorite BI tool, to your favorite notebook environment, and so forth. And you can then not only just unify all that data, but then you can actually curate a semantic layer so that way you can model your data and create that modeling layer where you create, your virtual data marts, or you create like a data mesh type representation or a medallion type architecture, whatever modeling approach sort of fits best what you're doing. You can build that in that semantic layer. So that way it's just much easier and intuitive to take the data that you've connected and deliver to where it's going. And usually in all that modeling, you'd have to kind of create different like materialized views and BI extracts and kind of add complexity to that modeling that also make it harder for the data engineer and data analyst to sort of execute this whole platform, reducing self-service. But with Dremio, you have reflections, which are a way to accelerate, that are easier for the data engineer to execute and easier for the data analyst to use, because they're just transparently substituted. So basically, these reflections are just going to be materializations off to the side, and Dremio will decide when to use them, because Dremio has an intelligent query engine that'll determine sort of when to use those. So that way your analysts can just worry about querying the data they know and getting the performance they need. But again, not only do you have access to that data, but you have that governance where you have basically fine-grained governance controls. So you can do role-based access controls, row-based access controls, column-based access controls, so that way you can be compliant with your rules and make sure that all your users only have access to the data you want them to have access to across all your data sources, controlled from one place, instead of having to create access controls across a bevy of different data platforms. Not only that, you have all sorts of integrations. So you can integrate with tools like Privacera, Ranger, et cetera, depending on your deployment, and then again have those rules honored wherever that data is being used. And we also have several different sort of certifications to show that security compliance. As you can see, these certifications here, whether they're in the health and other spaces. Again, the second pillar of what Dremio's value proposition is, it's not just the access to that data and governing that data from one spot, but being able to have a very fast query engine. Okay, a query engine that's built on Apache Arrow, which reduces serialization, deserialization, whether we're talking about when we're processing data in memory or transporting data over the wire between nodes. It just allows it to be much, much faster. Okay, allowing Dremio to have data, equal or faster data warehouse-like speeds on the data lake. Okay, and again, you have the reflections doing the query acceleration, and Dremio's architecture allows you to have unlimited concurrency, so you can always scale up horizontally and vertically to meet your needs. Okay, so you can always either have bigger compute or you can have more clusters. And again, all those rules can actually be automated and set up so that way you have automated scaling. And then again, our third value proposition is Lakehouse management, where basically the idea is that to get a lot of these benefits as far as cost and reducing your time to insight, you want to bring more of those workloads to the data lake. So that way you're, again, reducing the amount of ETL and all these extra steps to get to that end analytics. But the catch oftentimes is that data lakes don't manage themselves. You have to manage them. So in the past, you'd have to kind of set up your own compaction jobs, set up your own cleanup jobs to clean up sort of old expired snapshots. But Dremio can automate that away for you. So through our table optimization, you can automate the compaction of your tables. Through our automated table cleanup, you can automate and say, hey, only retain the last 7 days of snapshots or the last 90 days of snapshots, and Dremio will do the cleanup for you. Using our integrated catalog, which is based on Nessie, which will be the catalog we'll use today, you can create branches and have that Git for data-like experience that allows you to isolate data on a branch. We'll do an example of that later today once we're all set up, giving you that version control that allows you to tag different branches so that way you can replicate data very easily, so that way you can roll back when there's a disaster, giving you a lot of sort of flexibility on the data lake that you wouldn't otherwise have. So Dremio really kind of gives you all the tools to really take that data warehouse-like feel onto the data lake in an easy way. So easy, fast, and the thing that you don't get in the data warehouse, it's open. You can basically, using open formats, using open protocols, so the data really can come from anywhere and go to everywhere. So now that we've introduced what Dremio is and sort of what the value proposition of Dremio is, the next step is to actually go build our Lakehouse. So let me just kind of go over what the steps will be, and then we'll execute them. So this is based on this blog post here. I'll share this QR code again at the very end of the exercise. But essentially, if you wanted to do this again at home, this would be the blog post to check. It's our sort of Dremio, Nessie, Iceberg, Lakehouse on your laptop blog post that walks you through this exercise. What we're going to do first is we're going to use Docker, specifically a feature of Docker called Docker Compose that allows us to describe many different containers that we would like to spin up. And we're going to spin up 3 containers in a network to represent our data lakehouse. So we're going to have a Dremio container, which is going to basically be running the Dremio software, a Nessie container, which will be running the Nessie software, which is our catalog. Okay, and the cool thing about Nessie is that it's a catalog software, but it doesn't just work with Dremio. The Nessie and its Git-like features work with a variety of engines because it's an open source. It's an open source catalog, so you can connect to Nessie with Spark, with Flink, and with other engines, so that way you can take advantage of that catalog and make those tables portable between all your favorite tools. Minio is a object storage platform. Okay, and we'll be using that as our data lake. So basically, whether it's Minio, AWS S3, ADLS, Pure Storage, Vast, NetApp, whatever object storage or storage data lake platform you use, will fill sort of that role. But again, if you decide that you want to deploy Dremio into production, you got 2 approaches to do it. So while we'll do it with Docker today for evaluation purposes, when you go to production, you can either use our cloud-based SaaS or through self-managed, we recommend that you use our K8's Helm chart. Okay, our K8's Helm chart, which will actually have basically all the variables you need to fill in to properly deploy that into your Kubernetes environment, making it really easy. You just run the Helm chart. Okay, now after we spin up our environment, okay, we're going to create a warehouse bucket in the data lake. So we'll log into Minio and create a bucket in our object storage, which will then we'll configure to be where Dremio writes new tables. So as we do DML and create iceberg tables and update iceberg tables and delete iceberg tables, it'll all be done to this designated bucket. We'll then log into Dremio, and then we'll start connecting our data sources. And guess what? Once you've done that, you have a lakehouse. Okay, you can start running analytics. You can start connecting the data and start getting to the races. So lots of really cool stuff. Okay, so with that, let's begin with the exercise. So what I'm going to do next is I'm going to open up my IDE, and actually just as a practice, because I'm going to want to not go too fast and make sure that you guys are following along with me for those who would like to follow along. If you're just watching and you're not going to do the exercise as we walk along, still do chime in. What I'm going to do in the chat is as I do steps, I'm going to put them in the Zoom chat, and then I'm going to ask you to write like a complete or done in the chat, so that way I know you've completed it before I move on to the next step. So that way we're moving at a pace with the whole group. Okay, so first thing I'm going to do is I'm going to give you guys these links. This is a link to where you can find an abbreviated version of the steps we'll be following. Okay, so I'll give you that link for now. And then if you click the link or you're ready to move on, just give me a quick done in the chat, so that way I know you're ready to go on to the next step, and we'll begin there. So, okay. Now, basically, now that I have these steps, I'm going to put these steps off to the side so that way we can see them as we go along. And then I'm going to open up my VS Code. So again, you don't have to use VS Code. You can use your IDE of choice. But what I've done is I've opened up Visual Studio Code to an empty folder. Okay, just so that way I have my nice integrated terminal, really easily accessible there. But not necessarily. If you want to operate however you prefer to write the code, you can. But all I need to do in this folder is create one file, a Docker compose file, which is going to be docker compose.yaml. Okay, so there's my docker compose.yaml file. And then I'm going to copy this right here, which again, if you clicked on that link, you'll be able to see the what you need to have in that docker compose file right here. So I'm just going to copy and paste that as is right here. Okay, so simple as that. Okay, and we're going to go over the details of this as our environments spin up. But once I have this in there, okay, what I'm going to do is I'm going to have my terminal environment. So I'm going to open up a terminal to the folder where I have that Docker compose. So see, I have I'll run pwd, print working directory, and see this is opened up to the folder where I have this file created. Okay, so I have it, and again, it doesn't have to be VS Code's integrated terminal. It could just be a standalone terminal. Just make sure that terminal is open to that folder where you have this Docker compose file, assuming you have Docker installed. Then I will just do Docker compose up. Okay, and what this command is going to do, it's going to read my Docker compose file and basically spin up the environment that I have described in here. And that's, oops, let me just get rid of that extra space I just added. I hit Docker compose up, and now it's going to start setting up that environment. Now, a lot of these containers, maybe the first time you download them on your computer, so it's going to take a little bit longer than it's going to be for me. So I'll give everyone some time. Okay, so what I'm going to do is I'm going to say, create the Docker compose.yaml, copy over the contents, and run Docker compose up. Okay, and then as you complete those steps, do write done in the chat. Okay, but while everyone's environments are spinning up, what I'm going to do is I'm going to walk through what we see here in the Docker compose file, so we can understand what the contents here. That way, if later on you want to play with it and manipulate it, you'll kind of know what's going on here. So in this Docker compose file, the idea is that I am going to run several different services sort of in this imaginary network of computers. So essentially, each service that I create is a separate sort of You can think of it as a separate imaginary computer running a particular piece of software to keep it as simple as possible. Okay, so the first one I called catalog. So that's the name I gave to the service. And that's going to be the name of that container on the imaginary network. And what this one's doing, it's running the Nessie Docker container. So that's what's running our catalog. I'm exposing port 19120 because Nessie, the way you communicate with Nessie is via a REST API. So any tool that's communicating with Nessie will need to be able to access that REST API, which runs on port 19120. Okay, so that exposes the port. And again, this is just saying, hey, we want this on this network. So that way they're all on the same network and they can all see each other. Wait 1 second. Let me read this question. Alex, it's possible to simulate controller executor locally using Docker with the embedded Zookeeper of Dremio. You can set up a multi-node environment. Usually for demonstration purposes, I haven't done that, but you can. Now, basically, when we get to Dremio a little bit later, you'll see in there, there's actually a spot where you can add additional nodes to your cluster from the UI. So you could theoretically spin up a bunch of containers. If you know their IP addresses, you can connect that if you wanted to. But we'll come back to that. So, but usually for just trying it out and seeing it on your computer, I usually just recommend single node in this particular way because it's just is an easy way to get it up and running and just try things out. Okay. And again, once the environment has spun up, do write done in the webinar chat. Okay. Now the second service that we're going to be spinning up is Minio. So again, Minio is a object storage platform. And essentially what you're seeing here is that we're going to want to log into Minio later. So I'm using these environmental variables to specify what my username and password are. Okay, these pretty much just never change those. And I'm exposing the ports where Minio communicates from. Okay, and then finally, we're exposing Dremio or running Dremio, okay, using the latest version of the container. And then we have 3 ports here. So this port here is going to be where the web application is running from. So when we log into Dremio, we're going to go to port 90, our local computers, port 9047. This is going to be the port where JDBC, ODBC connections connect to. And then this is going to be the port for Apache Arrow type connections. Okay, depending on how you're connecting to Dremio to pull down your data. Okay, so this will be the web application, which also includes the REST API. So again, there's 3 ways you can connect to Dremio to pull data down. Either the REST API, which is a great tool for like automating workflows. So for example, you might want to create unique automations of certain activities on Dremio using Dremio's REST API. You can use any programming language and send REST API calls with the SQL to create new users or add access for a user to a particular data set and automate a lot of these things, which a lot of people oftentimes like to do. Again, JDBC, this is going to be generally where most BI tools will connect through the JDBC connection. And then like Apache Arrow, if you're using like Apache Arrow Flight, that'll be the endpoint for that. That's great for like when you're using notebooks. It's going to pull that data down really fast. Because again, when you're using Apache Arrow Flight, you're not converting the data. It's staying in Apache Arrow format. So in that case, you skip that whole, converting of data types between different steps along the transfer, which makes the transfer a lot faster. Really useful for very, very large data sets. Bottom line is the benefits you get over using Minio, S3, or any distributed file system is just the general benefits of a distributed file system in general. So for example, and if you're just watching, just give me a done, and then that'll tell me that I can move forward. If you're doing the exercise, either way, just that way I know who's moving forward. But back to that question, the benefits of distributed file systems are going to be sort of, that percent uptime because you get that redundancy that you can have because you're replicating the data across, possibly different machines. Scaling because basically, since you are using a network of machines, you can improve access when you have a lot of concurrent access to that data. So those would be the benefits over using sort of a distributed file system. And I think starting with like version 24 up, it's generally required that you use a distributed file system now for like reflection storage. So that would be my note on that. And again, that would be configured in the Kubernetes Helm chart. So if you're doing the self-deployed version, that would be deployed in the Kubernetes Helm chart. If you're doing it through the cloud SaaS version of Dremio, whatever is the cloud that you connect, AWS or ADLS, or basic, again, AWS or Azure, that will be sort of the object storage that will be used for storing reflections and things like that. Okay. In this case, since we're not using a Kubernetes cluster, I don't have those specific settings built into the container. So I'll talk about reflections a little bit later on. Cool. Okay, and I'll come back to the rest at the end. So I'll come back to that. Cool. Now let's see here where I want to go next. Okay, so now my environment should be spun up. Okay, so now the next thing I want to do is I want to create. And again, if I follow the steps in this link I gave you, all the steps are there. The next thing I'm going to want to do is go head over to Minio. Okay, so I'm going to go visit localhost 9001 because that's where we have Minio being accessible. So if I go to localhost, again, localhost represents our computer. And I'm saying, hey, on port 9047, my computer, because Docker is mapping those virtual computers to these ports, I can go access Minio. Oops, I went to Dremio. I'll come back to you, Dremio. Actually, I'll just leave it in that tab. And I'll open a separate tab, localhost. I want localhost 9000. Okay. So then it's going to open up Minio. And now the password and username and password I'm going to use is whatever I set up in these environmental variables over here. Okay, so that's going to be admin. And what I'm going to do is I'm going to take a little bit more space here. Reason being is really don't need, like after the environment's running, we don't need this anymore. But I'm going to keep it there so I can refer to it as we go. Okay. So admin. So those are my username and password. Again, how do I know that? Because it's in the environmental variables in my Docker compose file. I'm going to click login. Okay. I must have mistyped admin. Oh no, it's admin password. It's right there. I like saying, look at the Docker compose file, but I did not. Close. Okay, so then this is the Dremio. This is the Minio UI. So when you log into Minio, this is what you see. All we need to do is create a bucket, which is going to be this icon right here. So this will show me the list of buckets that I have, and then I can click Create Bucket. So I'm just going to create a bucket called Warehouse. Now the purpose of this bucket is to store any tables I create. Okay, so this is different than the distributed storage I configure for like reflections. That's configured elsewhere. This is going to be for actual tables that I write. So I'm going to create this bucket. I just create a bucket. Just need to have a bucket. Okay, nothing more complex there. Okay, and now once I have that bucket created, I can go to Dremio. But before I do that, I'll give everyone a second to see if we're there with me or ready to move on. Okay, so create a bucket in Minio. Give me a done if complete or ready to move on. So again, if you're just listening, you can just give me a done either way. So a done if you've done the thing, if you're following along, or a done if you're listening, just saying that you're good to move on. Okay. Perfect. Okay. So I have the container. So now I can head over to Dremio. And when I first see the initial time I go to Dremio in the browser, it's going to have me set up a user. So I'm just going to set up an initial user. Okay. Okay, I'm going to set up a password. Okay, and then here we see our Dremio environment. And I'm going to just make that full screen. Okay. Cool. Okay, so now at this point, all we have to do is connect our data sources. Okay, and basically what I can do here is I see here, this area right here says no data sources exist yet. Well, I can add a source, and there's several different data sources you can connect to. Okay, so if any of these data sources are sources you have as part of your data world, you can connect to them, including data warehouses like Snowflake, Redshift, and so forth. So you have Synapse. You can connect to NoSQL databases like Mongo. You can connect to SQL databases like MySQL, Postgres, Oracle, etc. So there's a lot of options on how you can connect your data. You can connect your data to different data lakes. So whether it's an S3-based data lake, which is what we'll be using in a moment, Azure Data Lake, Google Cloud, Hadoop, you can use that. You can connect to Nessie catalogs, which is what we'll be doing as well. You can connect your AWS Glue catalog to your Hive catalog, Lots of options. Okay, so you can unify all your data here on Dremio. Okay, so what I'm going to do is I'm going to choose a Nessie catalog as the source that I'm connecting to. Okay, and here what I'm going to do is I'm going to configure that source. Okay, and I know that I'm going to call it Nessie because it's a Nessie catalog. You can name the source whatever you want. You can have multiple connections to the same source because you might have them slightly configured differently. Have whatever you want to do. And then here I'm going to put the endpoint, okay, which is going to be this Nessie 19120 API v2. How do I know that it's called Nessie here? The reason is the way Docker Compose works is that all these containers, so that means Nessie, Minio, and Dremio, are all working on the same virtual network, and they can all see each other based on the name that I gave them. Okay, so this container name allows me to specify, hey, how do I want that container named on this virtual network? So I can then use that as the URL to connect to that. Okay, so that's the URL. Basically, we're using it uses the v2 version of the Nessie API. So it's /API/v2. Where basically Nessie, when you spin up the Nessie container, by default, no authentication. But there are different ways you can set up authentication with Nessie, whether it's like OAuth, you can actually use like AWS credentials. There's a lot of different options built into the Nessie software. But this allows Dremio to connect to Nessie. So this tells Dremio, oh, this is where the Nessie catalog is. So that way Nessie can communicate to Dremio. And what Nessie is going to tell Dremio is, here's where you find that table in your object storage. Okay, so wherever you stored your Iceberg metadata, Dremio still needs access to that too. It needs access to the storage of the actual metadata. Nessie is just going to tell Dremio where that metadata is, because that's what Iceberg catalogs do. Okay, so in this case, we're going to have this storage tab where we now need to specify where our data is stored. You're generally going to need to specify a bucket where it's going to be sort of the root path for this connection, where basically where's Dremio going to write your tables as you create them. So that's our warehouse bucket. So I just write warehouse. Okay, easy as that. And we're going to connect using AWS S3 because Minio is an S3 compliant object store. So basically we're using AWS this S3 connection. And for our purposes, our secret key, our key and secret key are just our username and password for Minio. So admin password. There we go. That's done. Now, the only other piece I need to do is that since we're using Minio, not S3, Dremio needs to be put into compatibility mode. So that way it's like S3 compatible source connection. So what we do is we're going to add some connection properties down here. The first one is going to be this one right here. Again, this is all detailed in that link that I provided earlier. This basically allows it to use S3 type pathing for Minio. So let's just set to true. Again, all this is also detailed in the documentation. Okay, this is the endpoint. So instead of sending it to the default AWS S3 API endpoint, we wanted to send it to our Minio endpoint, which is going to be technically storage 9000. Because if I go back to my Docker Compose, we named Minio storage. So that's why I'm going to use storage there. Well, we named Nessie, actually Nessie's catalog. So I need to go fix that. Because I think I wrote Nessie over here. Yep. So that's going to be catalog. Okay, and again, what that name is going to be is dependent on the Docker Compose file. So again, making sure you know what you wrote in the Docker Compose file. So again, Nessie's we called catalog, Minio we called storage, and Dremio we just called Dremio. Okay. So again, there's the endpoint, and then just one more property. This is dremio.s3.compat. That's just to turn on compatibility mode. Dremio.s3.compat. Okay, and that's going to be set to true. Okay, and then I'm going to click off this encrypt connection. So encrypt, when it's checked off, it's assuming you have there's going to be an SSL connection. Okay, so if I'm connecting to S3, that's going to be the case. If I have Minio running in production, that'll probably be the case. But since this is running on my laptop, there's no SSL certificates on any of these things. So in that case, I do not want that checked off. So encrypt connection off. Again, I'm evaluating. These are all not encrypted connections. Okay, and then that's it. So again, the information to connect to the catalog and the information to connect to the storage where all that metadata will be stored that Nessie references. I hit save, And then it should see, yep, perfect. So it connected, and there I have a source. Okay, so I have connected a data source. Okay, and I can connect as many of these data sources as I want. Okay, so for example, there's this sample source that's always available in Dremio. This gives you some sample data that you can work with. So I can just add that. That's technically an S3 bucket that you'll have access to. So you can, access some of the data that has on there. But essentially, that's the setup of connecting data sources. So I'll give everyone a moment to do that. Connect to data sources. And then give me a done if you've done it or you're ready to move on. And as far as that question goes, you can connect to as many data sources as you want. Okay, and that's the beauty of it, because Dremio can unify all your data. So I can go connect Snowflake. I can go connect an S3 bucket where I have Delta Lake tables. I can go connect another S3 bucket where I have Iceberg tables, and I am able to do joins across all that data without having to move any of it, making life a lot easier. And then I can create views from all those queries to curate, my data modeling for my users, and I can govern all that and set, what rules, what users can access the data set. For the users that can't access the data set, which rows and columns they can use. I have a high level of control over what's going on. Oh, you can connect directly to S3. The only reason I'm not connecting directly to S3 today is because the idea is that this exercise is something that you can completely do on your laptop, whether you have a cloud account or not. So this can be done by anyone, anywhere, without having to have a pre-existing cloud account. It's just purely Docker. So that is the reason for the particular setup today. But if you had an S3 account, you can just literally go connect your S3 account. Now, why am I connecting to Nessie versus using S3? Is that Nessie is the Iceberg catalog, and Nessie adds additional features of those like Git-like features, so I can do branching. So if I connect to the Amazon S3 directly, technically it won't be an Iceberg catalog. Like you can do Iceberg tables directly from S3, but under the hood, the catalog implementation that it uses for Iceberg is different. Whenever you connect directly to object storage to use Iceberg tables, you're using what's referred to as, in the Iceberg world, as the Hadoop catalog. It just means file system. So you're writing directly the files. The problem with the Hadoop catalog is that not all object storages and not all storage solutions have the same guarantees. So since you're depending on the storage to act as a catalog, it doesn't give you the same concurrency guarantees that it does of using an actual catalog service. As far as worrying about like consistency with concurrent writes. So with Nessie, you'll have that consistency, but you also get the benefit that's unique from all the Iceberg catalogs of merging and branching. So then you can take advantage of a lot of these patterns that you can't take advantage with other Iceberg catalogs. Okay. Oh, and far as this question about the Helm scriptway on a Kubernetes cluster, that is totally available. You can just go direct. I will show you where you can get the Kubernetes Helm chart at the end. But yes, there's a Kubernetes Helm chart that has everything you need to deploy this, in a straightforward way, because it's all pre-configured for you. Okay, and documented, so you know which settings to change if you want to change anything. Okay, but now that we have the catalog connected, or I have my source connected, and since this is, again, Nessie is an Iceberg catalog, I can begin writing tables. So now Dremio becomes pretty much a database. Like I can just start using this like I use any database. So what I'm going to do is I'm going to kind of organize this. So I'm going to go into my Nessie catalog, and I'm going to create a folder. Okay, and I'm going to create a folder, and I'll call it example 1. This will be our first couple of queries that I'll run. Okay, so there's my example 1 folder. And I can go here to Dremio, and I can start creating tables. I can just be like, create table Nessie dot example 1 dot names. Just standard SQL. Okay, and we'll have one field called name. That's a varchar. Okay, and the cool thing about Dremio is that you have this really nice SQL editing experience in the UI. Again, you don't have to do everything through the UI, but it's nice. And the cool thing is I can write multiple queries. Okay, so now I don't have to run this query and then do another query. I could go add my next query right afterwards. So I can be like insert into Nessie.example.names. And we'll say Alex Merced, Tomer Sharon, read Maloney. Okay. So there we have some, I'm going to insert. And if I run this, okay, it's going to start running the queries, and it's actually going to give me a tab for each query. What did I do there? So I have an error on the second one. Non-query expression encountered in illegal context. Did I insert into? Oh, I forgot the word values. Oops. Okay, that's a me issue. Okay, cool. So what I'm going to do is just change this to create table if exists, so that way it has that clause. I'll just comment out that line. Okay, and now I'm going to run this query again. Just get rid of this line. This whole thing again. Let's call it something else. Names one. I think I mistyped something in somewhere. True. Yep. So the table's created. And again, just to show you that it's actually working off our object storage, if I head over here to my object browser and I click on warehouse, I can see, like, there's the example one folder, and there's our two tables that I created. So I can see that the two tables were created. I can see the Iceberg metadata table is there, and all good. I also have some other really cool examples to show off some of the things that we're talking about here. So I'm going to give you guys this URL. So these are all examples that you could pretty much just run as is. Oh, that's what I was. Thank you. Thank you. I see in the chat. Thank you for telling me exactly what I was doing wrong. On this one. Oh, I see. I put example one there. Oops, there we go. Okay. There we go. If I run this one more time, just to illustrate the point. Oh, because it exists now. Okay. Let's just do this one more time. Oh, wait, because it's example one. That's why. My bad. You can tell it's Monday, right? There you go. Oh. Number of fields and the values cannot. Oh, it's one parenthesis per. You can tell it's Monday morning. One thing I've learned when I do public speaking is that sometimes, not everything always goes perfectly. So a trick that you can always do, just so you can use this in anytime you guys are speaking, is what you do is you say the day of the week. Okay, so what I do is I'll go, oh, Monday. It doesn't matter what day of the week it is, because what happens? Everyone's had that Monday, that Tuesday, that Wednesday. So then everyone kind of, laughs because they have like a moment where they relate, and that kind of breaks up the tension. Okay, so let me run that. Oh, but I forgot. I just created the table, so I have to do this one more time. This is all me. This is all me, a me issue. There we go. See, when the SQL is right, because my brain's working, it works. But there we go. So we created the table. But the beauty is I can see that I created the table, and I can go to another tab and see here that I've inserted the records. Okay. And again, all of that's going to be on my object storage, and I can easily go view that. Okay. And I can see all those tables that I've just created over here. Okay. So all of it is being created and persisted on my object storage. Okay. And the cool thing about this is that I could actually have multiple tabs. So if I'm working on multiple sets of queries, maybe working on different workloads, I can actually create multiple tabs. And then what I can do is that if, let's say, I want to save this and work on this more later, I can click over here and click save as a script and just say, hey, this is names. And now that's going to be saved over here for easy reference later. So that way I can use this. I use this a lot for like templates for like demos. So that way I can save a lot of my demo templates here and have quick access to them. But this could also be for like maybe you have an ETL job that requires a few different modifications, but you don't have to rewrite the whole script every time. You can save the script, then just change those little bits and bobs every time you use it. Okay, so this is extremely useful. Another neat thing you can do, so you can see one of the mistakes that I was making is that I kept messing up the namespace. I kept forgetting that one in example. That was my mistake, okay? But wouldn't it be nice if I didn't have to type as much? That would be pretty cool. So another thing I can do is, let's say I want to just do this. I want to just create table names, and we'll say names for. Okay, let me just refer to make sure I didn't create a names for. Okay, before my brain just stops. But let's see here. I go to names for here. Okay, now wait a second. It's like, Alex, it doesn't have the fully qualified namespace. How it's going to know that what you want to do? Well, there's this little thing right over here called the context swisher. And what I can do here is I can say, hey, this query that I'm about to run, I want it to run it in the context of this example1 folder. So that whole nessie.example1 is now assumed. Okay, so now when I run this query, okay, it's just going to be a lot easier. Okay, and this also helps me write out templates that are much easier to replicate because I'm not writing all these long namespaces and having to modify them every time I use those templates. I can just point to the right folder. Okay, so this also makes it a lot easier to make sure that your queries are where they are running in the context that you want without you having to type these long namespaces every time. Okay. On top of it, you have a nice little you can pull up the list of functions that Dremio has, and Dremio has several different SQL functions you can use to make life a lot easier. You can switch between light mode and dark mode. So a lot of really cool stuff there. And now let's go back over here for a moment. What I want to do is show you that I can also use Dremio for like a lot of, actually, you could probably use it for a lot of ETL work because I can actually create tables based on the sources that I have. So for example, I have this object storage source. So this would be like if you connect it to an object storage source. I click here and I click on samples.dremio.com. I see there's all these sample data sources. Okay. Now, at first, it just thinks that they're a bunch of files, but I can tell Dremio that these files are a data set. So for example, like this NYC weathers CSV file, I can just click right over here, and this allows me to format that data set and tell Dremio, hey, this is a data set that I can query. So I click format file. This could be a CSV, this could be a Parquet file, this could be a JSON file. There's a variety of options. Again, I take a look at it, make sure it's parsing it right. The only thing I don't see is it's not taking the column names. So what I do is I just click this little extract column names button here, and now it recognizes the column names because it knows that first row in the CSV file are the column names. I can hit save, and now I can query that. So I can query the CSV file, and that works just fine. And see, there I query the CSV file, and I queried it pretty quick. Okay, but let's say I wanted to turn that CSV file into an iceberg table. Okay, I could go back into here. I can go open up a different tab. So I'll use one of these other tabs I created. And what I would want to do is create that iceberg table in my Nessie catalog. So I can do something like create table nessie.example1 dot weather. This is the weather table. Okay, and then I'll do a create table as statement. And then this will just be a select star from. Now, do I really want to type that whole namespace to the weather thing? It might be really long. Let's find out. I have this section over here where I can actually browse my data sets. And I can be like, okay, there's my weather CSV. I can just drag it right here. Okay, and there it is. Okay, create table Nessie example weather as select star from samples. And I can hit run. Okay, and it's actually going to go now take that data set, and now I've actually just now moved it into my data lake. So now if I refresh here in Minio, see there's my weather table, and now I have it as an iceberg table. And again, iceberg tables are going to be read faster than CSVs. So in that case, if I have really large CSV tables that are not performing as well as I'd like, I might benefit from being able to just move them over to CSV. Move them over to Iceberg. And I can do that pretty easily without having me to go write some complex Spark job and spin up a separate Spark cluster. I can do a lot of that. There's a lot of DML that you can run directly from Dremio to do a lot of that data movement if you need to. Okay, cool. Now, a cool thing as well is, again, I can start curating that data. So when you're on the software version of Dremio, you have this section called spaces. Okay, if you're in the cloud version of Dremio, you essentially have the same thing, except this will be another Nessie catalog that's built into Dremio Cloud, because Dremio Cloud will give you a Nessie catalog right out of the gate, built into the software. Okay, so you don't even have to set it up, deploy it. It's just built in, which is really neat. And it's like really, really integrated, so you can get the benefits of like branching. And again, I'll show you the branching and merging in a little bit. Okay, but what I can do here, whether it's the Nessie catalog in cloud or the integrated catalog in cloud or spaces here in software, I can begin organizing my data. So for example, I might decide I want to do like a data mesh approach. And so I'll create like a space for each of my potential data products. So there might be like a marketing data product. And I might want to create a accounting data product. I might want to create a supply chain data product. You get the idea. Okay. And then what I can do in here is I can go into each of these folders and maybe I think, okay, how do I want to set this up? Maybe I'll do a medallion architecture within the data product. So maybe I go in here and I'll create like a bronze, silver, gold type folder. Okay. And then what I can do is I can grant access to users who I want them to have access to that data. And I can actually grant access to other users to have control of that folder. So that way, if I have my different data teams who are doing data mesh, I can give someone control of that accounting space so that way they can connect their own sources and curate their own data within that folder and be able to share it with others. So that way you have that collaboration in a really easy to use place. So regardless of whether they have their data is, so they might be using, some of that data they might have might be in Snowflake, some of it might be in a SQL database. They can then connect it, curate that data in that space that they have access to, and then share them amongst each other. Okay. And again, it can all be governed with the same role, column, row-based access controls. But for example, let's say I want to put something in there. Let's say I'll go back to that weather table. Okay. So here I have the iceberg version of the weather table. I query it. Okay. If I want to put that in my space, I'll just click save view. So I'll click save as a view. So I'm not saving it as a script. I'm saving it as a view this time. I just go into, hey, I want to put it in the accounting space. And let's say this is the raw data. I can just go here. I'm going to put this in bronze. Okay, this is the raw data. So we'll just call this like weather raw. Okay, and now that's in weather raw. Oh, yep. Because it's in my Nessie catalog. Because a Nessie catalog can have multiple branches, to create a view, you do have to make sure you specify what branch you're working from. So add branch main. Main is the default branch. So let me save that view again. Save as view. Okay, go into accounting, bronze. We'll call this weather raw. Okay, and hit save. Okay, and basically there it is. So again, someone else, when they log in, they may not see everything here because you didn't give them access to everything here. You may have only given them access to the accounting space, but now they have access to that. If you give them access to the specific folders, they can see the raw weather data here. They just see a view of it, but they can then curate additional views. So I might go in here and say, hey, this is the raw data, but really I don't want all of this. I just really want, station and name. So let's say here's station and name. Okay, for example. Okay, so there I have that view. And again, I can save this as a view again and say, hey, put this in my gold folder or silver folder. And we'll say this is weather silver. And then again, you can go through each of those layers doing those ETL changes. Okay. So that you can create those virtual data marts there. And the cool thing is, like, again, you don't have to do this all from the UI. Any SQL that you see that I've been sending to Dremio through the UI can be done through all those interfaces that I mentioned before, either through our REST API, either through JDBC, through a JDBC connection or ODBC connection, or through an Apache Aeroflight connection. And lots of tools take advantage of those connections, such as our DBT integration. So all of this could be automated via DBT, so that way I can curate all these layers and just set that up all as DBT models that are in code, that are checked in the version control. And basically, you just edit those models, rerun those models, and it'll update Dremio. Okay. And we do have a video showing that whole DBT process that I will include in the follow-up email for this workshop. Okay, so some of the cool features you can do with Dremio. Again, you have all this access control, this ability to connect all your data sources, organize it. It's very, very nice. And again, if I'm that data engineer who's adminning all of this, I can kind of monitor everything from here. So I can see all the queries are coming in. I can see who's setting those queries. I can see whether they're accelerated by reflections, what data sets they're querying, where is those queries coming from. So in this case, they're coming from the UI. Which you can have different queues. So you can actually do what's called workload management. So on cloud, you can actually just do that all from the UI, where you can set up different clusters of different sizes and when they turn on, when do they turn off. and then say, hey, these queries, like these users, their queries go here, or these types of queries go here. So that way, low priority queries aren't using premium compute, but your high priority queries have premium compute that's available to them. And you can set up all those rules. So that way you can manage your costs based on the importance of the queries that you want or the kinds of queries that are coming in. Okay, and I can click on any of these jobs and I can get more information about how they work. So I can see here a breakdown of sort of where the time is being spent for troubleshooting. I can even download a query profile where you can see everything broken down. So basically, if you have Dremio support, you can take this query profile and the Dremio support team can really break down and find out exactly what might be the issue with a particular query. I can go over here and take a look at the SQL and see the graph. So you can see here in this query, I'm querying the bronze data, okay, which requires access to the raw view and that original weather table that was in my query. So I can kind of see like, hey, what am I accessing? And then you can see this really detailed profile. So this would be what you would download. But here you can see it in the UI and see all the details of the query. Again, this would be for like the admin to use, so that way they can diagnose where bottlenecks may exist. And again, also again, you can do workflow management to kind of make sure that you're directing jobs where you want to direct them. So on software, you see like this whole queue control where you can control the different queues you have for queries. And here's where you would like add engines. So like if you're if you do the Kubernetes Helm chart, the Kubernetes Helm chart will take care of a lot of this. But again, here I can go add another node to the cluster, just fill out this information. In Dremio Cloud, that's really easy because you can just it's a much simpler setup because it's cloud managed. So you just say, hey, I need another large cluster. I need another small cluster. Shut it down after 5 minutes of no use. It can be replicated 5 times if needed. So that way you always have the exact level of concurrency and queries being routed to the right place. So in this case, at the end of the day, your analyst experience, they just query data and it just works. But the engineer's ability to deliver that experience becomes a lot easier because they can govern all that data in one place in an easy to use way. They can accelerate it really easy with reflections. So for example, let's pretend that weather data, if I go back to the weather data, let's say I wanted to accelerate this particular view. I would just click here where it says like edit. Okay, that would take me to this screen right here. And then there's this reflections feature. Okay. And from here, I can do acceleration. So if I was accelerating BI queries, I would just literally click here on aggregation reflections and hit save. That creates reflections, and then Dremio takes it from there to swap that out when needed. So that's all it took for me to accelerate queries for BI dashboards. If we're talking about raw queries for raw rows, I can just turn on raw reflections, and I could just hit save, and that pretty much be the equivalent of a materialized view. But again, the end user, the analyst, doesn't have to be aware of it. They're just going to notice that they query the same table, and it's just now faster. But I can go even further because with raw reflections, I can click on this advanced column and I can specify which columns should be included in that materialization, how that materialization should be sorted or partitioned. So I can really tailor materializations that are really fast for particular use cases. So you can have multiple reflections on the same view or table. And again, Dremio will figure out which one's the best one. So instead of the analyst having like 5 materialized views for 5 different use cases and having to know which one to use, you, the engineer, would just create 5 reflections, and the analyst only queries one table, and the right reflection will be used, making life a lot easier for them. And creating those reflections are really just point and click, really easy. And nowadays we have a reflection recommender built in that actually monitors the queries on your cluster and will recommend you which reflections to make. What is a reflection? Good question. A reflection is essentially a materialized. The best way to think about it is think about like what a materialized view does. You're creating sort of a copy of a thing you're trying to make faster. So essentially, I might have a petabyte size table, but I only really need to query like a gigabyte of that data. So then you create like a 1 gigabyte copy of the data you need, aka materialized view. But a materialized view oftentimes is a little bit more work because you're creating all these extra things that the analyst has to be aware of. Because there might be materialized view 1, 2, 3, 4, 5, each of them for a different purpose, and the analyst needs to know that. So it's a little bit more work on the engineer and on the analyst because the analyst then has to update it. Reflections, Dremio does the updating. So Dremio will update the reflection on a cadence, and the analyst doesn't have to know when to use it because Dremio will use it for them. Dremio will be like, hey, you're querying this view. Your particular query would benefit from this reflection. We're going to use it. So in that case, you just get that extra benefit. Yes, in the previous versions of Dremio, I would say 23 and before, the question is like, when you install Dremio locally, does it use the file system to store reflections by default? Yes. In versions 23 and before, you had a system called PDFS that it would use to store them locally. And what that stood for was like pseudo file system. So it was like a pseudo distributed file system. But starting with version 24, you are required to have a distributed file system. And then again, that gets configured in a particular file that would have to be edited in the Docker container. Or again, if you're using the K8s Helm chart, it's in the K8s Helm chart, you would just edit it there. So 23 and before, yes, you could just use a local file system, but to achieve best performance and resiliency and runtime, it's standardized now to be a distributed storage for that storage. And again, not something you have to think about with Dremio Cloud, because Dremio Cloud, all that stuff is just taken care of for you as a managed system. So it's just off to the races. Okay. Cool. Oh, yep. I just realized we're just about out of time. Okay. I do have a lot of additional content on different examples. Like if you go to the Dremio YouTube channel, I have loads of videos on different examples and showing you all the different features in Dremio. So I would recommend checking that out. I will also include in the links for the follow-up links for the REST API, links for, and then also links to some other the videos that show you many of the examples that you can try. And again, that link I gave earlier actually shows you the SQL for many of those examples, so that way you can actually try them at home with your setup. So I'm going to stop here because we're about to hit the hour. This video will be uploaded to the Dremio YouTube within 48 hours and also available on Spotify. So you can also subscribe to the Spotify podcast for this show, A Gnarly Data Ways, so that way you never miss an episode. And so that will be available. And again, feel free to add me on LinkedIn because I'm always glad to ask questions. And let me just give you this QR code here. That's where we'll end off at. This QR code actually is the link to the blog where you can do this exercise again anytime you want. Has all the details in a blog format. And thank you guys for showing up. There's so much cool stuff going on in Dremio that I lost track of time because it's just an amazing platform that brings you so many amazing features. And to really kind of see all of it, you really got to get hands-on with it and try it out. It really makes that Lakehouse story really easy to execute, powerful, and transformative to your data practices. So you guys have a wonderful day, and I'll see you all next time on Gnarly Data Ways. Thank you very much.